Hi everyone. In the last video, we have seen various types of technical interview questions and how to find out the output of the code snippets. In today's session, we will discuss one more example. After that, we will implement the logic to find out the factors of a given number. After that, how to implement the logic to check whether a given number is perfect or not. So mainly we are going to see more C programs using while, do while, and for. First, let us go to the technical interview question. You see this. When you observe this code snippet, every C program starts with the preprocess statement. Execution starts from the main, and here we are declaring the variable character ch. C, we are taking the value ch equals to 123, and the type of the variable ch is character. That means it is signed character. The range of the signed character is, we already discussed, minus 128 to plus 127. So what would be the output of this code snippet? See, the output we are going to get when you execute this is 124, 125, 126. So here you write /n to print the output in the next line. 127 and minus 128. This is the output. Here you write just /n to print the output line by line. 124, 125, 126, 127, 128. This is the output. How we are getting this output? See here, the range is from minus 128 to plus 127. The values, the range of values are stored like this. We are starting from 0, plus 1, plus 2, plus 3, plus 4, and up to plus 127. After plus 127, it stores the value minus 128, minus 127, minus 126, and so on, minus 1. This is the representation of signed numbers. Here initially we have taken ch equals to 123. Okay, 123. Now ch value 123 is compared with 0. 123 is greater than 0. Yes, the condition is true. Now after this, automatically ch value becomes 124, and in printf, first comparison done with 0. The value of ch is 123. 123 is compared with 0, and it is incremented by 1, and it prints ch value 124. Next semicolon is there. The control is passed to a ch plus plus. So first ch value how much? 124. 124 is compared with 0, and it is incremented by 1. Next it prints 125. Next 126, 127. So see here, ch value how much? 127. 127 is greater than 0. Yes, it is true. But whenever it crosses the right parenthesis and whenever it enters into printf, ch is incremented by 1. Now it is going to print minus 128. First 123 is the initial value. It is compared with 0 and incremented by 1. It prints 124. It is post increment, means one value is advanced. So 124, 125, 126, 127, finally 128. Now next ch value becomes minus 128 is greater than 0. No. In this case, what happened? The condition becomes false and the control is passed to return 0. So here the output is 124, 125, 126, 127, and minus 128. If you write in place of ch plus plus ch and greater than 0, in this case we are going to get first value is 124 pre-increment, right? So ch value 123, so 1 is added and it is assigned 124, next 125, 126, and 127. Here it is not going to print minus 128. So this is the way of representing the numbers, and the output of this program is 124, 125, 126 up to minus 128. Now what we are going to do, the first program we are going to implement is how to find out the factors of a given number. factors of a given number. See, before going to write C program, first you have to implement the logic. If you know the logic, then directly you can write the program, any program, not only C program. How to find out the factors of a given number? For example, you take any number 6. We call this as n is equals to 6. The variable here we are taking is n. What type of value we are storing? 6. 6 is integer. Okay. Now, how to find out the factors of this number? As a human being, we directly say that the factors of 6 are 1, 2, 3, and 6. Directly we can say. But the computer has to give the factors, right? The computer doesn't know any intelligence. So it blindly checks each and every number by dividing n with starting with 1, next to 2, 3, and up to 6. So what we are going to do is take a number 6 and divide 6 with 1. First we are starting with 1. 1 6 is 6. Yes, the remainder is 0. We are taking the remainder. To take the remainder, we use the modulo division. We use the operator is modulo division. Now, if it is divisible by that, the number n is divisible by 1, then we can say 1 is the factor. Next, we are going to divide the same number 6 with 2. 2 3 is 6. Again, we are getting the remainder 0. Then 2 is also a factor. Next, take the number 6 and divide with 3. 3 2 is 6. Yes, the remainder is again 0. 3 is also a factor. Take 4. 4 1 is 4. Yes, the remainder is 2. Here the remainder is not 0. It is 2. Then 4 is not a factor. So, this is the logic to write the program. So, mainly if you observe this logic, the important thing is we are taking the variable is n. Next, we are dividing n starting with 1. So, to store next 1, after that we are checking with 2, 3, 4, up to n we are going to divide. So, for that you declare another variable called I. Now, initially you take I equals to 1 and you divide n with I and take the remainder. If it is 0, then you would say it is factor. Okay, if it is not divisible by 0, it is not a factor. The logic here is n percentage I equals to 0, then I is a factor. This is a way of finding the factors of a given number. After finding the factors of a given number, for example, we have given n equals to 6. What are the factors? Factors for this are 1, 2, 3, 6. These are the factors. Now, what is the sum of the factors? The sum of the factors is 1 plus 2 plus 3 plus 6. How much? 12. So, we are going to implement the program to find the factors of a given number and to find the sum of factors of a given number. After that, we are going to write a program to check whether a given number is perfect or not. What is perfect number? Take a number n. If n wants to be the perfect number, then what you do is take the factors of n 1, 2, 3, and 6, but you don't take itself as a factor. Then what are the numbers we have? 1, 2, 3. Now take the sum 1 plus 2 plus 3 is equals to 6. We are getting n. So in this case, you would say that n is the perfect number. What is a perfect number is, the perfect number is find the factors of that number, not itself. 1, 2, 3, and you find out the sum. If it is equals to the original n, then you would say that number is perfect. So this program also we are going to implement using 3 loops. So we are writing the program using 1 loop. After that, we will change into the remaining loops. This is simple logic. After this, we are going to find out the sum of even numbers. Sum of even numbers. After that, we are going to see the sum of first n natural numbers. and natural number. So these type of programs we are going to see. So let us execute the C programs to find the factorial of a given number, to find the factors of a given number, and perfect number program, and some more program that we will see. Let us execute those programs. Now we will see the programs. So first I'm going to write the C program to find the factors of a given number. Next to sum of factors. Next we will see perfect number. After that we will see to find the factorial of a given number. So first program is to print the factors of a given number. Program first, let us say first I'm writing the comments. Program to find, or we can say to print the factors of a given number. Print the factors of a given number. Program to print the factors of a given number. You know, hash include is the first statement. stdio.h int main. Okay. So just now I said the logic, right? So we need a variable like integer n, another variable is I, right? Now you say printf, enter any number slash n double quotes semicolon. Next you write scanf percentage d double quotes ampersand n semicolon. Now you start I with I equals to 1. How to find out the factor? Just now I said that take the number n and you divide n with 1 first, next 2, 3, and so on. So first we are going to divide that number with 1. So that's why I'm taking initial value of I equals to 1. Now I'm going to print the factors of a given number using while. First I'm explaining about while. Now after initialization, you know the syntax of while is like this: while so start I with the 1 and you go on divide n up to n. So here what you do, while I is less than or equals to n, use this logic. While I is less than or equals to n, in this case what you do is you have to say if divide n with modular division, you have to use modular division n I, divide n with I and take the remainder. If the remainder equal to 0, then what you have to do is if n percentage I equals to 0, then printf percentage d. I'm writing slash n to move the cursor to the next line. Here you print I. I'm printing the factors. Okay. Now after this, I'm saying I equals to I plus 1. I'm incrementing the variable I. And finally, here I'm writing return 0. This is the program. We'll save it and we'll run the program. Okay. So in the output, it is asking enter any number. Okay. I'm giving the number 6. Now what it is printing? 1, 2, 3, 6. 1, 2, 3, 6. These are the factors. Okay. We got the correct output. I will explain the output, how we got the output. This is enter number. So removing semicolon. I will explain the program by each and every instruction. You see here, this is the comment hash include stdio.h and the execution starts from main, integer main, and we need two variables, right? Integer ni. Now enter any number. It is asking enter any number. So from the output, the output device we are giving some input. Assume that we have given scanf n value we have read 6. Now initially I equals to 1. So we are going to take I equals to 1. Now take the condition here, while I is less than or equals to n, I value how much? 1. 1 is less than or equals to 6. Yes. Why? Because we are assuming that n equals to 6. 1 is less than or equals to 6. Yes, the condition is true. Then it enters into if statement. N, we are dividing n how much? 6. 6, and we are dividing with 1. 1 6 just 6, the remainder is 0. So left side we are getting 0, right side is also 0. It is equals to 0. When it is equals to 0, the printf statement is executed. Now it is going to print the value of I. How much? 1. After printing this value, next I value becomes I plus 1. How much I value now? 2. Now again it goes back to while condition. I value is compared with n. I value is 2. 2 is less than or equal to 6. Yes. Then divide 6 with 2. 2 3 is 6. The left side value is 0. Right side also 0. Now again it is printing 2. Next I value becomes 3 here. Next again the control is moved to while condition. 3 is compared with 6. Yes. Now divide 6 with 3. 3 2 is 6. The remainder is 0. Again it is true. It is printing 3. Next I value becomes 4. Again 4 is compared with 10. 4 is less than or equal to 6. Yes. And divide n. N means 4. Sorry, n value is 6. Divide with 4. 4 1 is 4. The remainder we are getting is 2. But it is not 0. In this case, the condition is false. This condition is false. When it is false, this printf statement is not executed. Please remember. For the value of I equals to 4, the printf statement is not executed. So it is printed 1, 2, 3, but 4 is not printed. Why? Because this condition became false. Now again the control is passed to I equals to I plus 1. I value becomes 5 now. Now again it moves the cursor to the beginning of while. 5 is less than or equal to 6. Yes. Come down. Check the condition if n value how much? 6. Divide 6 with 5. 5 1 is 5. The remainder is 1. Again, we are not getting the remainder 0. In this case also, this condition becomes false. This printf statement is not executed. For 5 also, it is not executed. Next I value becomes 6. Again, it goes to this condition. 6 is less than or equal to 6. Yes, the condition is true. And here again, 6 divisible by 6 is the remainder is 0. Yes. In this case, the condition is true. Now the printf statement is executed. Now I value is 6. It is printed for 1, 2, 3, and 6. The printf statement is not executed for 4 and 5. Next I value becomes 7. Now again the control is passed to beginning of while. 7 is less than or equal to 6. No, the condition is false. So finally the while condition is false. When it is false, this block is terminated. Now the control is passed to return 0, and here the program terminates. So in this case we are getting the output 1, 2, 3, 4. No, not 4. 1, 2, 3, 6. That's the output we are going to get. Let us run once again. You can take any number, enter any number. For example, I'm taking 8. What are the factors we are getting? 1, 2, 4, 8. Okay. If you take the number again 6, we are getting the values 1, 2, 3, 6. The factors of 6 is 1, 2, 3, 6. That's all. This is the program to find the factors of a given number or to print the factors of a given number using while. If I say implement the same program using do while, easily you can convert into do while. So let us do some modification. Simply do, just you write do, everything is same. I equals to 1 is also same, but here instead of writing while condition, just you write do. Next everything is the condition is tested. Last here you write while, and in this case you say I is less than or equals to n, condition is here, and you put semicolon. Do while ends with semicolon. That's all. Everything is same. Now once you run this program, 6, again we are getting the same output. Now same program can be written by using while, using just while completed, do while also completed. Now using for, simple thing, simple modifications you have to do. For what you do is just you write for. Okay, now initialization is done. Just you take this statement here, and here you write it next, and condition you take. What is the condition? I is less than or equals to n, and here you write I is less than or equals to n, condition completed, semicolon. Where is the incrementation? This is the incrementation. Now you write here this incrementation, right? Now after this you write if n percentage I equals to 0 stays remaining, you delete delete. That's all. So here don't put semicolon, last one. Now you run it. So it is asking again, enter any number. I'm giving 6. You got again 1, 2, 3, 6. So this is the way of writing the program, same program, but we have implemented using while, do while, and for loop. So once we know how to find out the factors of this number, now you can find out the sum of the factors of a given number. Now, how to find out the sum of the factors of a given number? See, in printf, we are printing the numbers here, right? Instead of printing the I values like factors, just you have to find out the sum of those numbers and you have to print it. How to print? So to print the sum, what you do is you take a variable here, sum. Any variable you can take. Now first we are, what is the first factor? 1. Next factor is 2. Next one is 3. Last factor is 6. So first factor is 1, right? So you have to add 1 to some variable so that the resultant value again becomes 1. Again should become 1. So that type of variable you have to take, that variable is sum. You add 1 to sum such that the sum remains 1. What is the initial value of sum? Can you guess what would be the initial value of sum? In this case, you take sum equals to 0. Sum equals to 0. Now everything is same. I equals to 1, 1. Now you do one thing. If n percentage I equals to 0, then don't print here. You find out sum equals to, you add sum plus, instead of printing I, you add I to the sum. Now in this case, what happened? This sum equals to sum plus I is executed for 1. 1 is added to 0. Next result becomes 1. Next 1 is added to 2. Result becomes 3. Next to that result 3 is added to 6. Total how much we are going to get? 6. So finally we are going to get the value is 12. So within this for loop, what happened? It is repeated up to n. Means I value becomes, last I value becomes 6. 6 is less than or equal to 6. Yes. Finally I value becomes 7. 7 is less than or equals to 6. No. Condition false and it goes to return 0. But before return 0, you do one thing. You printf sum sum of factors. Sum of factors is, just use a percentage d slash n and comma sum. Now if you run it, see it is asking a number. Enter any number. For example, I'm giving 6. The sum of factors of 6. How much? 12. So this is the way to find out sum of factors of a given number using for. Not only for, you can use while, do while, any loop you can use. So now what I'm going to do is I'm going to change the same program to check whether a given number is perfect or not. How to write that program, that we will see. Program to check, just I'm going to change the program title. Program to check whether a given number is perfect or not, using I'm using while. Okay, you can use any loop, but I'm using while. Okay, now everything is common, hash include, main, everything is common. integer IM sum. Okay, enter number, everything is same, but here I'm not using for, I'm using while, right? While what you do is, while I is less than or equals to n or less than n, you have to use the condition less than n. Previously we have used I is less than or equals to n, but we are using I is less than n. Why? Because we are not taking the same number as a factor. So that's why we are using the condition I is less than n. And before entering into while loop, first take I value as 1. You can initialize I equals to 1 at the beginning or anywhere you want. I equals to 1. So 1 is less than n and n equals to 6. If you take n equals 6, 1 is less than 6. Yes, it enters into if, and here it is going to find out the sum. Right now, after this, after closing brace, what you do is, instead of printing the sum of factors, just you check if sum is equals to given number n. Then you say printf given number percentage d is perfect, and you write slash n. Else you do one thing, you write the same code, given number percentage d is not perfect. In place of percentage d, you have to write n value, here also comma n value. So this is the logic, this is the way of writing the program. I will explain with an example. See, whenever you execute this program, we will execute this, we will check. Okay, now we will see the program. So here we didn't increment I value, let's say I equals to I plus 1, I equals to I plus 1. Right, now you save it and run it. Now it is asking enter any number, you write 6. Given number is perfect. We got the answer, right? Now this is a simple logic of to check whether given number is perfect or not. Take the number and read the number n, and you first take I value as 1, check the condition. If the if condition is true, then only some statement is executed. In other cases, some statement is not executed. And finally, we are checking the condition. If sum equals to n, then the given number is perfect. Otherwise, the given number is not perfect. So this is the program to check whether a given number is perfect or not. So with this, I'm going to close the session. Thank you for watching.